Hi, my name is Ahmet Coksaygili. This is Project 1, submitted for Design and Manufacturing to Hassan Rashidi. All of the sources required for the slide will be at the right down corner. I hope you enjoy the presentation. Our first subject is Design for Manufacturing. Design for Manufacturing, or Design for Manufacturability, is the process of proactively designing products to optimize all manufacturing functions while ensuring cost, quality, and reliability, and also product evolution for market demands and surges. Why DFM is capable and important? DFM is very important because it reduces time to market, as manufacturers doesn't have to bounce ideas again and again from the manufacturing state, so they can go with their initial design and go to market faster. It reduces manufacturing costs and manufacturing time as you optimize for it. It sets cost and capabilities-based goals design structures into process, which allows the designers to act more efficiently. And it also increases manufacturing flexibility and capacity as your throughput increases and your manufacturing ease increases. What are the applications and limitations of DFM? Any process which requires physical manufacturing or related physical manufacturing can be done with DFM. The limitations of DFM. DFM is not a check or design review. Let's look at this one singular part and its DFM review, right? There is multiple axisymmetric conditions for a singular part. This has to be done with concurrent engineering. It has to be done not after the engineering is done, but while the engineering is getting done. The DFM is also not done on the parts level because most of the gains for manufacturing purposes are actually on the systems level, but you can design multiple parts together to get the most out of your manufacturing capabilities. DFM cannot fix poor production definition or cost estimates because basically what your manufacturing estimates and how you optimize for manufacturing is based on these two criterion already. Also, DFM requires the designers and manufacturers to embrace do it once, do it right principle, where in the case of an engineering change or a manufacturing method change, at the middle of the design phase will basically scrap the entire design. Our second concept is design for assembly. Design for assembly, similar to DFM, is proactively designing a product to optimize for all assembly functions, while also balancing cost, quality, reliability, and modify the product evolution for market surges and market demands. Why DFA is capable and important? By its name, it is designing for an assembly, so it reduces assembly and labor costs. It enables higher production capacity and flexibility through shorter assembly times, as your parts are easier to assemble, and it ensures reliability through preventing assembly mistakes, especially critical parts with critical orientations. Designing for DFA can allow you to get rid of assembly defects through just designing for that one singular orientation. What are the applications and limitations of DFA? Applications for DFA is any system with significant part or quantities to be assembled. The limitations are basically DFA can and will intersect with DFM. Sometimes something is more easier to manufacture in a different orientation or a different design than it's easier to assemble, so they are going to be intersecting with each other. As we said a bit earlier, like DFA is not a check or a design error. It has to be comprehensively done on a systems level and on a parts level while you're concurrently engineering it. And DFA has to be conducted as a system level as well. In general, right now, the general trend in the industry is actually to merge DFA and DFM to call it DFMA, where both of the cost factors are considered while designing and optimizing a part. And this is the main approach that is taken by most of the industry professionals right now. What is just-in-time manufacturing? Just-in-time manufacturing or just-in-time production system is a market-oriented production system only for serving client needs. So just-in-time manufacturing is known as just having your materials at the time of manufacturing and having no inventory basically, but that is not just-in-time manufacturing. There are multiple principles there. One of them is flow manufacturing, where flow of materials is unconstricted. The other one is manpower reduction, where every worker in a line is basically working at full efficiency. Manufacturing visualization and Kanban systems for detecting anomalies or detecting problems in a line. SMED for having high turnover rates for different designs. Mentality and worker contribution to make sure that the bottlenecks in the manufacturing line are found by workers. And 5S factory standards for making sure a factory is oriented and designed in a proper way. Why GIT is capable and important? because it tackles 7 plus waste in manufacturing. It tackles overproduction by making sure that lot and batch sizes can flow through the manufacturing line. It tackles waiting, as you are making sure that system is always flowing. It tackles unnecessary transportation. In a system always flowing, there is no storage cost, there is no transportation from or to storage. It tackles overprocessing or incorrect processing, because any kind of processing mistake results in a bottleneck in the system, so you have to design for manufacturing or assembly as well with it. It tackles excess inventory, because you do not want to incur inventory costs. It tackles unnecessary movement, again making sure there is no defects or no overprocessing. Make sure that there is no parts going in and out of a manufacturing line at different parts. It tackles defects, as they cause bottlenecks. And most importantly, it tackles unused employee creativity, using them to optimize the design process. GIT can be done in manufacturing contexts, but it is most effective in buyer-dominated markets with high production volumes. In low production volumes, GIT is more hassle than it's worth, and in sellers markets, because you can sell at any given price, it is actually more beneficial and more profitable to have stock, so you can sell at a higher point. The limits of GIT are: GIT is not an inventory management or a production management system. It requires engineering attention and principles such as the FMA, otherwise you will have bottlenecks in your flow. GIT cannot be executed with just implementation of Kanban or visualization techniques. If there is no flow of manufacturing, Kanban can be great, but it will not actually help with the manufacturing itself. There's a Kanban diagram right there, by the way. GIT is not resilient to economic shocks or manufacturing disturbance. It assumes that the flow of materials from outside suppliers or resources is constant, which is not the case for pandemics or huge factory fires. What is robust design by analysis, or Takeuchi's method? Robust design by analysis refers to two specific aspects of design and quality control: quantification and optimization of manufacturing defects through loss functions. For most mechanical manufacturing, this is the nominal, the better loss function defined by Takeuchi. Design optimization through analytic analysis and experimental analysis is also a part of robust design, where partial derivative analysis or experimental design analysis through Takeuchi's matrix are done. Why Takeuchi's method is important and capable? It reduces manufacturing variability, as you optimize your manufacturing designs based on the variabilities that you know, which will also result in better and usually cheaper production costs, as you have less defects. It reduces the amount of experiment required to characterize a system or a defect, which is always profitable. It allows for characterization of multiple integrations in a system, where factorial analysis will require thousands of experiments. With Takeuchi's, you can get it down to 10 or 8. Here we can see a Takeuchi's matrix and also partial differential analysis of an optimization. What are the applications and limitations of Takeuchi's applications? Takeuchi can be done for any manufacturing systems. However, for smaller production runs, characterization might be not as effective, as you need multiple experiments. So it can be said that it's not feasible with smaller production batches. It's also sometimes not feasible with multiple variables in the system, where you need a focusing experiment to find the variables that you need to basically actually experiment for. What is PLM? PLM is the activity of managing a product from conception to disposal. It focuses on 5 stages: imagination phase, IP rights, idea generation, definition phase, design phase basically, realization phase, manufacturing and manufacturing optimization and manufacturing tracking, use support phase, customer support, warranty, that kind of stuff, retire and disposal phase. As the name implies, disposal of the materials. Why PLM is important and capable? Sometimes PLM is just required by industry. Aviation and nuclear are one of the more famous ones. An effective method to find production irregularities or common manufacturing defects, as you're tracking a product through the entire manufacturing line. It increases customer satisfaction if done right, as you can offer warranties and you can offer checkbacks on your products. It also able to aid product evolution, as you are always checking back with your actual customers. What are the applications and limitations of PLM? PLM is applicable to all products manufactured or not. PLM is especially important in critical industries such as infrastructure, medical, and aviation. However, PLM approaches are highly dependent on all actors in the chain to be responsible and active. if the actors are not responsible or active. For instance, if they are not disposing through your disposal program, your disposal phase is completely gone. PLM systems are highly data driven. Therefore, integration of logging of key data points is important. If you lost data in a PLM system, you might not be able to characterize the system properly. PLM by itself is not a solution, but rather it's an amalgamation of techniques such as DFM, DFA. Therefore, it cannot be applied just as a software, but it has to be applied as a company-wide procedure and philosophy. In the end, thanks for listening to me talk about these SPI production techniques, and I hope you enjoyed my presentation.